In this video, as part of a bigger series, we're going to look at wiring a one-way lighting circuit within a conduit system. And in the previous video, we discussed the rig that I'd produced and whether you'd like to make one yourself and how you could go about that, as well as the rigs that you might have at college that are similar to this, so you can get that fundamental understanding of the conduit looping method, which is different to wiring lighting circuits than the 3-plate method we use in a domestic dwelling. This video also links to a series of videos I've done on wiring diagrams, which I'll leave in the eye above my head, as well as a link in the description below. And I recommend, if you haven't already filled those wiring diagrams out, it would be a recommendation before you start wiring these that you get an understanding from those drawings. And we'll use those drawings in this video to help plot the route of the cables, but we may make some changes based on things like the number of conductors in a location and how we might look to extend the circuit in the future. Those drawings were ones that looked like this. So we had one that was labelled a one-way lighting circuit, which had a consumer unit, it had a switch and it had a light, and we fed our cables through, in other words in pen, to the required locations in order to make that work using the conduit looping method. The drawing also here was one that we did very early on that didn't have any circuit protective conductors on, but did plot the route of the line and neutral when the circuit was using the conduit looping method, using PVC singles. So those two drawings and the information we give in this video will help us understand where we're going to put the conductors. However, we're not going to do the second fix, we're just going to insert the conductors. It's the first really in the series of this videos where we're actually wiring. So I want to get us used to pulling the cables in and thinking about their locations. So we'll install those as part of our first fix, and then we'll follow it on with another video where we look at terminating the ends correctly, or maybe having to do a little bit of bending the rules. Maybe there won't be no doubling over at certain locations because the size of the terminations are so small in some of our accessories. So we're going to look at putting these PVC single insulated cables through the conduit system in order we can first fix our one-way lighting circuit. So from our consumer unit here, from the 6 amp MCB, we're going to wire to a lighting point which is going to be positioned here and controlled from a switch just here, which matches perfectly to the pack that I've given everybody to download in my wiring diagrams, which will also be in this video in the description as well. So there's the rig that I described in my previous video and how to build one in 20mm conduit, and we're going to do stage 1, which is switch number 1, controlling lighting point A, and we're going to wire in 1.5mm squared PVC single cables, light A controlled by switch 1. So that's the job. The wiring diagrams we've produced previously in that series of videos will help us. So this one here is for a one-way lighting circuit. So we come from the consumer unit to the switch, from the switch to the light, and from the consumer unit with the neutral we go to the light. And we said previously, didn't we, that the CPC is missing from there, and the CPC can take the logical route it needs to do. And we also produced this diagram where we tried to pull the cables in and through using our pens into logical locations. However, I've changed it slightly, haven't I? Because consumer unit, our light's going to be positioned here and not over here. And obviously we drop down to our switch. So this will also help us. I'm going to start with the neutral. So the blue neutral starts within the consumer unit, and if I follow it through on both drawings, it goes straight to the light. Okay, so let's have a look at this one. My neutral, which starts in the consumer unit, goes straight to my light. So both drawings help us wire this circuit in PVC singles. Our neutral goes straight to the lighting point. Just to recap then what we're talking about when we're using our PVC single cables, they're class 2 conductors, they're stranded. They're stranded for greater flexibility, and we use 1.5mm squared as our minimum size for wiring in conduit lighting systems because it can stretch when being pulled in if it was only 1mm, and it's stranded for greater flexibility. So that's why we're using those. Single insulated with PVC, okay, and it's thermoplastic PVC, so it has a maximum operating temperature of 70 degrees. And the conduit, in this case, the black 20mm conduit, is offering the mechanical protection. And we know in twin and CPC cables, the mechanical protection is offered by the grey outer PVC. So single insulated conduit provides the mechanical protection. So this is our consumer unit. We're happy with that. Remember, you might have a one-way consumer unit, 6-way, whatever you've got. I'm more concentrating on the circuit breaker being our 6 amps. And we said in our previous video that we didn't need an RCD because this is not a domestic lighting circuit. We're simulating a commercial or industrial one. But let's have a look at our RCD. It is rated at 30 milliamps. and I don't like it because it's an AC one and it's an RCCB, so it's protecting these two circuits. The RCDs just happens to be here. Don't go to your college and say my lighting circuit when it's commercial industrial definitely needs an RCD for additional protection. It just happens to be here by default. So we've got our 6 amp type B circuit breaker matched to our load because we're only going to have either LED or compact fluorescent lamps in. So we don't need this to be, say, a C type or a D type. So we've got a B type breaker, 6 amps. So we're going to take our neutral conductor, and I said it's going to come from the consumer unit, and it's going to go straight up to our lighting point, so a little short run for us to go, and we're going to pull it in one at a time using logic. In the real world, and we said it in our last video, we'd pull all these conductors that go through this 20mm conduit through this route at the same time to prevent them rubbing against each other. So another conductor rubbing against here would cause friction, and that friction could burn through the PVC insulation and cause us a big issue, especially when we do our insulation resistance testing. So we're just going to pull the neutral in on its own. In the real world, all the conductors in at one. To make it easier for ourselves, little top tip from Gary, just fold the end over, because it gives us a little bumping area here, and that can help us when we're trying to clear through the conduit, say at the angle box just here. Sometimes it will knock against the sections between the two. It could be here as well when we're pulling it through. So by folding the end over, it might make it easier to pull it in, and also making it a little bit straighter, so just straighten through your fingers. So we're going to pull our neutral, or push our neutral up to this point here, which isn't needed, and we're going to take our neutral round to our lighting point. So it comes just up to here. Now, that's probably a little bit long. Now, in the past, I wouldn't have been too bothered about that, but let's think about the fact that obviously copper cable is not cheap, so maybe let's keep it down to a realistic length. So that'll be plenty there. And obviously when we get to our consumer unit, it goes at least to the bottom here and curls round slightly. There'll be plenty there as well. Just remember, your college is trying to save cables, but also they need to be the right length. We need to be able to dress them round. So there's a compromise there. There's plenty here because our neutrals are eventually going to get to here, and there's plenty up here that we're not being ridiculously short, but also we've not wasted a ton of cable. And there's a chance that we could reuse this cable again in the future because of the route it's taken. So our neutral, as we said, went from our consumer unit and it went directly to our lighting point on either drawings. So from our consumer unit to our lighting point. It might be that our terminations in our consumer unit are in different places, etc., but we're following that logical route through. Next, let's concentrate on the brown line conductor. It's coming out of the overcurrent protection device, and that was our 6 amp breaker. And our line conductor in the conduit method doesn't go to the lighting point. So it comes and it goes exactly where it's needed. It's needed at the light switch. It isn't needed at the light. And we know that when we look at our light points that we're going to use for this job here, and we said it in our previous video, we haven't got the loop terminal. We've got a connection for our CPC and a connection for our switching line and neutral. Remember, it doesn't matter which way around they go, whether that be neutral or switching line, neutral or switching line, doesn't matter, because again, when we turn it over, we can see we've got our 2 connecting pins for a bayonet cap lamp, and we know those lamps have no polarity. But what we haven't got here is what we see in the 3-plate method, that block which is called loop, because it's there because our twin and CPC cables run together. So you think of a twin and CPC cable, the permanent line, neutral and CPC are stuck in one cable as they make their route. Well, this time, because we're using PVC singles, we can go anywhere we like, and we don't need our permanent line at our lighting point. We need our permanent line to come down to our switch. So when we operate the switch, the switching line only comes back. So if we look at it on here, this is simpler from our consumer unit. Our line conductor, our permanent line, comes straight into the switch, and it will be eventually in the next video terminated in the common terminal. And then a separate cable from our switch goes to our light. That makes sense, doesn't it? You do not need the permanent line connection at a light fitting when you can take it anywhere you want to, and that's what you can do in the conduit system. So we can take our brown conductor anywhere we would like to take it. So if I bring in my 1.5mm squared single insulated stranded cable, fold over the end to make it easier. And this is the bit where you're repeating the same task, aren't you? A cable is going up this conduit, so again, it would have been better to pull them in at the same time. So let's poke that one up here. So this one is coming from the top of the breaker, and we do not need it at our lighting point, so it's not going to come here. We need to make sure it's long enough to get down to where it is actually needed, which is at the switch. So we're going to pull it through this part of the conduit system. Might want to leave a slight loop there at the top and then bring it down to the switch. So that's where our permanent line connection is going to be for when we second fix. That will be connected into the common of our one-way switch. Our permanent line is here. When I operate the switch, a switching line conductor, which we need to add, will go back and turn on our light. Let's confirm that. So from the switch, we come back with a separate conductor to our lighting point so we can turn it on. Let's look at this drawing here, which is slightly laid out differently. From L1, we come back with our brown conductor and it goes directly to our light. That makes sense, doesn't it? So we're going to come again. Let's cut this one to length. Let's make sure we leave it just about longer than the consumer unit. And we're going to go from our switch to turn on our lighting point. Permanent line down to common. So this will eventually be connected in our common terminal. And this one will come back as our switching line connection. Fold over the end. Put it into our conduit system. And we're going to push it up there until we get our switching line 1 up here. Again, be careful on your length. We don't need to waste too much cable. That's our switching line return. And again, you might want to just indicate that one by putting a little nick in it as our switching line connection. However, what's great about a conduit system is if we were unsure when we came back to this job, say we've had a break time or it's a different lesson, you're trying to work out what that conductor is. If we give it a pull, we can see it obviously moves both ends. And we've worked out that one is our switching line conductor. And this one here, if we're trying to work it out, it becomes the one that goes to the consumer unit. Okay, so that's really good. So our permanent line went to common, our switching line returned up to our light point. That's it finished. We don't need anything else. And you're thinking to yourself, Gary's got it wrong, there's gonna be a big edit now. Let's think about our accessories. An insulated box, insulated conduit, insulated light fitting, and there will be an insulated switch on here. They're all made of plastic. We don't need a CPC to run around this circuit. There are no exposed conductive parts. However, we're still going to pull our circuit protective conductor in, because what's to suggest that this light fitting isn't changed and replaced for one that is metallic and therefore would need a CPC, or the actual switch box here is changed. And I said in a previous video that we could have wired it in this style of switch and box, which obviously is metal and is an exposed conductive part, and the CPC would be required there. So we're going to pull a CPC in. However, the smarter people amongst you would say it doesn't actually need one. Pretty much practice on site, even though it's fully insulated, would always be to pull a circuit protective conductor in. Now this is where we can be a little bit more inventive about where we go with the circuit. It seems logical, doesn't it, that our CPC will go from the earth bar to our light and from a light to a switch. Let's have a look at our wiring diagrams. This one here did a different route. It went from our earth bar, our CPC actually went down to the switch and then across to the light. It might have been that that was the shortest possible route or the most logical route. Now we're going to see that as we move through this series of videos, where I'm going to be stuck with the size of the terminal, and the size of the terminal is the one in here. That is not very big at all in order to get my CPCs in. I have done off camera, I've managed to get 3 in there, but believe it or not, they weren't twisted and they weren't doubled over. They were just stripped and inserted, which is obviously people are taking a deep breath. Gary, are you going to do that? Well, we're going to have to see how logically we're going to wire our CPCs. I think we can comfortably get 2 conductors in all of these terminal holes. So for this part of the drawing and this part of the wiring circuit, I think we can go with the following. We could take our CPC directly to our light. So from a consumer unit, our CPC can go to our lighting point, and then we'll drop a separate one down to our switch, which would be logical in the real world. Imagine this was 5 or 6 meters and this was the lighting point. Would you pull the CPC from the earth bar to the switch and then from the switch back to the light? Probably not, because you'll have a ton of extra cable that you've paid for and pulled in. This rig is really small and obviously it's not that much of a concern, but we're going to try where possible to keep those routes logical. The CPC would go from the consumer unit, be dropped off at the light because it's the first point in which it gets to, and a separate CPC brought down to the switch. As we move forward, we might find we have to bend that rule slightly because we can't get the CPCs in these lighting points because the terminations are really small. So CPC from our earth bar, again 1.5 single insulated PVC, fold over the end. Going to push it through and we're going to get it out here. And we're going to take it to our first point, which is here. Now, it wouldn't be worth at this stage now cutting it or anything, so I could cut it and pull a separate one in, but let's think logically now what's going to happen. The next one's going to come down to here, so let's just continue pulling. So pull our CPC down to here. You're thinking, hang on Gaz, you said not to do that. So we've got our CPC down there, we've got a little loop at the top here. So what about now if we just cut that loop? So we can pick the CPC that comes now in, and the CPC that goes down would now be done by that. So that saves us sort of pulling another cable in. Early stages, you become very logical. A CPC goes from here to here, you cut it. And then you bring a CPC from here to here, and then you cut it again, which is fine. But let's think about trying to maximize our effort. So we need to cut our CPC off at our consumer unit. Okay, and we've got our one-way lighting circuit wired in PVC singles. We're going to go back through what we've done. We could use our drawings to confirm it or the knowledge that we've built up throughout those wiring diagram videos that we've done before. Let's start with the neutral. Our neutral came from our neutral termination within our consumer unit. Our neutral's gone straight to the lighting point because that's exactly where it needed to be. Our line conductor, so the permanent line conductor, didn't need to be at the lighting point. It was only going to be there in the old method that we used to use in domestic dwellings, the old 3-plate method. When I say old, I mean just the method we use in a domestic dwelling. So we needed the actual line conductor to get to the switch, and it does. So this line conductor here comes down to here. So that's our permanent line from the consumer unit to our switch. When we operate the switch, so when I make and break a switch, so when I operate that switch, we need the switching line connection to be on the other side of the switch. So this one here comes up to our lighting point in order to turn it on. That's our switching line conductor. We've added the CPC in case these are changed for exposed conductive parts, and we've used our CPC in a logical route from the consumer unit. It will be terminated into our earth bar. The CPC goes to the lighting point and a separate CPC down to the switch, and they will be there in case we ever turn them over to metallic fittings in the future. That's it wired. That's our basic one-way lighting circuit wired. It's a variation of this drawing. So again, we move the light from here into this position here, and you're meant to use your knowledge gained in order to make those connections. We could use this wiring diagram, which we did very early on in that series of videos. Again, no CPC in here. So our CPC actually went to the light point and then to the switch, but we didn't add it in on this drawing. We obviously added it in on the rig that we've just wired. So that's our one-way lighting circuit of office number 1 done, which was suggested was part of the paperwork that I was going to do at stage number 1. So if I bring that paperwork in, stage 1, we wired light A controlled by switch 1. So light A controlled by switch number 1, and that's what we've just wired in PVC singles using the conduit looping method. In the next video, we'll look at terminating the ends and dressing the cables. It is quite difficult to make them look really neat because they're PVC singles, but we'll make off the switch and the straight skirted batten lamp holder before we extend the circuit. So we're in office number 1 now. What we'll do next after we've done the second fix video is go on and we'll do office number 2, we'll wire it. So we'll work out how to wire this one and office number 3, and then we'll apply the knowledge that we understand from this video and the one where we terminate the ends of the conductors in order that we can make off all those connections. So hopefully that's walked you through how to wire a one-way lighting circuit using the conduit looping method, using diagrams we've already produced, as well as using the logic and sense about wiring this circuit. So in the next video, we'll go on and we'll terminate the ends, but hopefully this video has been some help.